Hi, this is Mike from Unknown Tech. Today we're actually going to put our DYI DGX system to use. And so we're going to install a few things. I'm going to set up the system. So last time on the blog post I left you at the foundational core services and software that was installed. Again, this is a do-it-yourself DGX workstation. It cost about a little under $2,000. It's running on a Minisforum AR900, or excuse me, AR900i, which runs a 13900 H Intel CPU, which is a mobile CPU variant. It has 96 gigs of DDR5, 5600 memory. It has 4 NVMe drives, one for boot drive for Ubuntu 2404, which we installed in the, which I showed you in the previous blog post. And now we're going to basically set up the solution to actually service AI models and do some testing. So in order to do this in a simplified manner, right, instead of actually going through and manually creating model endpoints, etc., we're going to set up a couple pieces of software. The three pieces of software that I've chosen are Ollama, which is basically a solution that will provide access to open source models and serve those models. The second thing I have installed is Open WebUI. And the third thing I've set up is access to Open WebUI to nvidia NIM. Right? So this allows us to take advantage of the best of both worlds, both on open source models through Hugging Face as well as NVIDIA. Now, before I did that, I actually had, again, I have 4 NVMe drives in this system, in the 4 M.2 slots that I have. One is for the OS Ubuntu 2404. That's what I'm running here. The other is a 2 terabyte Hynix Gen 4 drive, which actually has Windows 11 Pro installed. I'm not going to dual boot into that yet, but that's how it's set up. This is a dual boot system, so you're actually able to boot into Ubuntu 2404 or Windows 11 Pro. In this case, we're just going to focus on the Ubuntu system. Then I have 2 crucial P3 1 terabyte drives, and the first thing I wanted to do is set those up in an LVM stripe and use that storage, right, for my model storage. And so that's the first thing I did when I post install of all the foundational drivers and the software that I talked about in the original blog post. So let's look at that now. So if I do a ls block, you can see here all the physical devices I have, and you can see here I have the NVMe 2N1. This is only a 250 gigabyte NVMe drive from excuse me, this is a drive that's actually being used for the Windows partition, which again I'm not using right now. We'll get into that later. NVMe 3N1. This is the actual OS drive for Ubuntu 2404. This is only 250 gigabytes, a very small NVMe drive. It's a Samsung, I believe a 970 or 980 Evo drive that I have. And then I have the 2 crucial P3s, NVMe 0N1 and NVMe 1N1. And you can see here the directory I created, AI models directory here for the LVM. So these two are set up in a LVM stripe using ext file system. And I created a directory called AI models. So if I cd and mount into AI models and I do an LL here, you'll see that I actually have 2 subdirectories within this directory, one for Ollama and one for NIM. Okay, so this is basically the storage for both NIM and Ollama. I won't talk about NIM yet. Let's talk about Ollama. So after you install Ollama, you're going to actually have to update the service. Okay, so in order to do that, you actually have to go into the service configuration and actually point it to the storage location here. Okay, so you can see here in the actual Ollama service configuration under environment, okay, you can see here that we have environment Ollama models under service, and it's pointing to MNT AI models Ollama. So this tells Ollama to actually store the models in that directory. The second thing I did is I want to expose Ollama to an external interface, right? So if you don't do this, what will happen is you'll only expose it to the local interface, your 127.0.0.1 basically, okay? and you're only going to be able to access this locally in this machine. So I've basically exposed the Ollama service to all the interfaces. I only have one active interface on this box, and so the 5 gig interface that I've installed on here, that's exposing this service. And this allows me to connect external solutions to Ollama, right? To use Ollama as a model service endpoint, okay? And then use different applications. In my case, I'm using Open WebUI. So again, let's just talk about what I did so far. I created an LVM stripe on those 2 drives. I created the directory for the AI models. I've installed Ollama, okay? And I've made sure that I point my model directory to that directory for Ollama, as well as set up the Ollama service to be accessed externally. Okay, so that's what I've done thus far. So let's get out of here. Okay, and now when you see here, if I do an LL on the AI models, you can see here I have Ollama. If I do a CD Ollama, CD manifests, CD registry, CD library, okay, you'll see that I have one model downloaded, and that's the GPT OSS 20 billion parameter model. Okay, because remember, I only have a RTX 4000 SFF8, excuse me, and that GPU only has 20 gigabytes of VRAM, right? So I wouldn't be able to use the GPT OSS 120 B model. All right. Now this is the trade-off, right, from an nvidia DGX Spark, an official one, right, to the do-it-yourself Spark, which I'll summarize in my blog post here. Okay, but what's happening is the trade-off is I'm saving $2,000, right, on the Spark, and basically getting 90% of the functionality of the Spark versus the 20 gigabyte limitation on the do-it-yourself DGX and the 128 gigabyte theoretical maximum on the DGX Spark. And the DGX Spark can't use all that memory anyway, right? Because there has to be some memory left over for the system. But still, being able to leverage a good portion of that memory gives you the ability to run much larger models. Secondly, I just want to talk about what else I did here. So let's get into Open WebUI. So if I do a Docker PS, you can see here I have Open WebUI actually configured. And I'm not on this system. This is going through JetKVM, right? The external. Remember, in my requirements, I wanted to have external, access to the system. Of course, I could SSH into this. I haven't set up SSH yet, right? I'm going to do that. But right now, I'm just using my JetKVM interface to connect to the system. Now going back to my PC, when I log into Open WebUI, it's going to ask you to set it up, right? It'll actually just ask you to set up Open WebUI, and it'll ask you to create a login, password, etc. Now, remember that I want to use Ollama for the open source models servicing, but I want to use basically the NVIDIA Docker Container Toolkit with Docker for my NIM models. So that toolkit is going to allow me to service models from NVIDIA, right? That's a separate platform, so to speak. And so I have to be able to have Open UI or Open WebUI connect to both of those. Now, how do I do that? So by default, Open WebUI will connect to your Ollama instance. Okay, so as long as it's on the same machine, you can set that up. Okay, or excuse me, it'll automatically be configured. I did download a GPT OSS 20B model. It's not running on Ollama right now because I can only run one model at a time. Okay. Now, how do I access the NIM portion in Open WebUI for testing? So what you have to do is you have to go down to your user. You have to go to the admin panel, and you select settings. Within the settings, you'll see a link for connections. Okay. And you can see here that I have already my Ollama API, right, already set up. And by default, this is what Ollama is actually using, right? It's actually running on port 11434. Okay, so when I basically kick off a model, it'll use hostdocker.internal and then this port 11434 by default. This is already pre-configured in Open WebUI. You don't have to configure this. Okay. Now, if you do have trouble accessing Ollama, I suggest you click the link here for help, and it'll walk you through the process. But essentially, this should work fine. The other thing you have access to is Open AI API. Okay, so in this case, it automatically provides, when you go in here, you won't see the second thing here. I'll talk about this in a minute. But you'll see at least the link to the OpenAI API link. And so you can actually connect to OpenAI API models, right? Could be going across the internet and connecting to the OpenAI endpoints if you would like to. Now, NIMS uses the OpenAI API, okay? And so what you can do here is you can actually set this up to point to the machine, which is the DGX, do-it-yourself DGX system we built on port 8000 using V1. And this API with port will automatically point to the NIM models because that's how you build the NIM models. And so now we're going to show you how to do that, right? So now that we're configured to set up and test, what you have to do now is you actually have to go back into your system and you actually have to deploy a NIM model. You can see here I've already deployed the Nemotron Nano 4B NIM, okay? So what we're going to do is we're going to test both. We're going to test the Ollama open source model access, and we're then going to test the NIM access via the OpenAI API custom endpoint that you put in the configuration of Open WebUI. Okay, so let's go back here. And what I'm going to do is I'm going to delete this NIM to show you how I installed it. Okay. So I'm going to stop the Docker container, and I'm going to remove the Docker container for this model. Now, the good news is that this model is already stored right in the NIM directory I showed you, right? So if I go into cd mount AI models, we go back into this, cd NIM, cd ngc, cd hub. You can see all the models I've actually run already, right, on my solution. And so what will happen is when you go out and you build these and you deliver or you set these models up, right, to actually run, it'll pull the model down. And because I've configured it to store the models on the NIM subdirectory within AI models on that LVM striped, right, and M.2 storage solution, it's going to store it in this NIM subdirectory. Okay, very simple. You can look that up on how to do that. I use Warp, and so what I can do here is I can actually go in and hit Control I, and I can actually use the Warp terminal to actually configure that for me. Okay, now I know you might think, well, that's cheating. Well, my view is this: if I don't know how to do that, and I want to learn, having a system show me to do that, right, is actually pretty ingenious in a sense that I can get access to this information right away. Okay, and that's the time I'm saving to do that. And so what I'm doing is I went through, I asked the question, how do I use this directory to store my NIM models, right, next to my Ollama models? And it basically said, you have to do this, this, and this, and then ask me, would you like me to actually execute that for you? Okay, because this Warp has the agentic or agent mode built within. So that's what I love about this terminal. Let's go back to the terminal here using Control I, and you can actually do that through either here or you can actually click here to agent mode as well, but I use Shift I. So you can see the model's already there. So now we're actually going to run the model. Now you're probably thinking, okay, Mike, how do I actually do this? Before you use anything NIM or NVIDIA NIM related, okay, you actually have to set up your solution to actually be able to do that. All right, so the first thing you need is you need to have a NGC account. Okay, so I have an NGC account. I have an API key that I've created. I created it back in March. I actually use this for Nutanix Enterprise AI as well. But for this local workstation, right, and how we're going to service this, I'm going to use this key that I have, all right? And what I'm going to do first, obviously, is export my NGC API key. And the reason you have to export this is you have to actually use this key to get access to the models that NVIDIA allows you to have access. Now, you don't have access to all the models. I will just tell you this straight up, okay? Right, we're in build.nvidia.com. You're not going to have access to all the models, but you will have access to a good amount of models, all right? Some of these models will work, and some of these models will not work, right, based on the system that you have. In this case, again, I have an RTX 4000 Ada, has 20 gigabytes of VRAM, and so I'm not going to be able to use the GPT OSS 120B or the Nemotron Super 49 billion, right? I just don't have enough VRAM to accommodate that. And so that's why when you saw the models that I have downloaded already, they're very small. So again, going back to trade-offs between this system and the DGX Spark official system, right? You'll be able to run much larger models on the DGX Spark. And it depends on what you're doing, right? So, my view is the DGX Spark is really purpose-built for that true AI developer, right? AI application developer, data scientist, AI developer. And the do-it-yourself DGX Spark that I built is really built for inferencing, right? You can do development on here. I'm not saying you can't. But what you really lack is the VRAM to do any fine-tuning or training, right? And that's what you wouldn't be able to do on the do-it-yourself solution. So that's one of the trade-offs. In my world, it's really all about inference, right? And the applications that connect to these smaller models, right? That's really what it's about. It's about building agents, using SLMs, using inference, right, for chatting with documents, right, using RAG. In my world, that's what I need. And so that's why I built this system instead of having to go out and spend an extra 2K on the DGX Spark system. So keep that in mind. Again, it always goes back to your use cases, and it always goes back to trade-offs. You have to look at both of those things, meaning define your use cases first, look at the trade-offs if you over one over the other when you do the comparison, and then make your decision, okay? So going back, I know I went off on a tangent there, but I think it's important. You actually have to export your NGC API key, okay? And you don't have to normally export you can export this once, right? Or you can configure this in your bash configuration, right? So you can set this up for all of your current bash, active bash session, okay? Where you can define where the cache is, right? And the cache is, in my case, defined, right, in this directory, in the NIM directory. So I know I went further, NGC Hub, but it really is this NIM directory under AI models, okay? And that's where the cache is defined. The next thing you have to do is you're going to have to, you don't need to make a directory, I've already made it, right? So in your case, you may want to do a directory, but if you do this local cache here, right, and you set this up, what you're doing is it doesn't know where this NIM cache is. So you have to configure your directory to point to the subdirectory where you want your model stored. In my case, I only have 250 gigs on my OS drive, right? That's a very small drive, and I want to be able to download multiple models, and I have an LVM that's almost 2 terabytes, right? A striped LVM on 2 other NVMe devices. And so I want to leverage that for my model storage. So you have to define that, and then you have to export those settings. Then it says you want to do Docker run, and this is basically how you pull the model down, right? It'll download it, and it will then deploy it. Now, some things I want you to keep in mind. You have to understand what these settings are, right? And in my case, of course, I'm going to use all GPUs. I'm not going to use SHM because I don't have multiple GPUs. So SHM would be used if you have multiple GPUs in a system that can be shared, all right? And meaning they can be shared across a PCIe bus, all right? In my case, I have 1 GPU, so I don't keep this in. The NGC API key, right? I basically point to this, and I'll show you how I do it. I point to my environment variable, okay, which I've already defined the NGC API key. The cache I specifically put in the folder. I'll show you what that looks like. I don't use an ID user because I'm already logged in as that user. The port is 8000, and then this is the model directory. It's basically a registry, right, where we're pulling from, and this is the NVIDIA model registry. Now, I'm using the Nemotron model, and so let me just go back into the system and show you what it looks like to actually deploy this. It's going to look a little different than what I had here. Okay, so you can see here I'm doing a Docker run -d. The name is the model name. Okay, in my case I'm doing the Ollama 3.1 Nemotron Nano 4B version 1.1. I'm selecting all GPUs, of course. Notice that I didn't put in the shared memory configuration setting because I don't need that. But I do have my NGC API key, which is my environment variable I've already exported. Okay, so I've exported that for the session, and therefore that's what it's leveraging. And then you can see here the mount AI models NIM and NIM cache. Okay, so basically it's saying the NIM cache for this model will reside in this directory. Okay, my port is 8000. I choose to restart unless stopped, and then this is the registry, right, that it pulls from. Let's go ahead and launch this now. Now, this will look a little bit different because I've already downloaded this model, it's actually pulling right from this directory here instead of downloading it. So that's why you don't see the image pull. It's already here. I already have it. And so it's basically just running the Docker image that I already have stored. So if I do a Docker PS, now you can see that my model is started. Okay, 24 seconds ago. Let's look at the logs. And so this is going to take a little bit, but essentially it's not ready yet. Yeah. So what will happen is when that model is ready, okay, essentially what it says is basically you can continue to look at the logs. You can tail the logs to see exactly what's happening. And you can look at the logs and just have it, watch the logs, right, of Docker. You don't have to actually just, do the logs every so often. You can just watch the logs in real time to see exactly when it's finished. And then when you're done, you can actually do a curl command against the API. Now you could do that. I'm not doing that because I already know that I already have my Open WebUI configured correctly. Okay. Remember I went in here under my settings. Under my admin panel under settings. That gets a little, right? And I already have this configuration already set. So when that model is ready to be serviced, it'll show up in Open WebUI. And it hasn't showed up, it just showed up. So now it's ready. So if I look at the logs again, okay, you can see here that it's ready to go, right? Unit is running and the model is basically ready to go. All right. So now it just showed up in Open WebUI. So if I click this, I can now test it. So let's just use the current test. So now you can see here that I'm now using Open WebUI to access NVIDIA NIM models that I've actually deployed through the NVIDIA Container Toolkit using Docker. Okay. Very, very simple. Okay. So now that that's done and we validated that the NIM models worked, let's start looking at open source models through Ollama. Okay, so because remember, NIM is one side of it for the NVIDIA side, and Ollama is the other side of it, really for the open source models via Hugging Face, etc. So what we're going to do now is we're going to go back in here, and we're now going to delete. We're going to stop the Docker container, and we're going to remove it. Okay, so if I do a Docker PS, you can see here that the container's not there anymore. Okay, And if you go into Open WebUI and you refresh, that model is now gone. Okay? So now what we're going to do is we're actually going to go into and use Ollama. So Ollama has its own command line. Okay? So if I go Ollama PS, there's nothing running right now. If I do Ollama list, you can see here I have this model already downloaded, which is the GPT OSS 20 billion parameter model. 13 gig in size. So this will fit into the RTX 4000. Okay? And remember, you're not trying to get to the 20 gig. You don't want to go and say, I want a model that's going to take up to, whatever it is, 19 point something gigabytes at the end of the day, right, for VRAM, because you still need, a good portion, a portion of that VRAM for KV cache. And so there have been models I've downloaded in NIM as an example that I've deployed, which I think should fit on the 20 gig RTX 4000, right? But the model will fit, but there's no room for KV cache. So I'll be like 1 gig short for KV cache for context. And so that's a problem, won't run. So you have to be very specific, and you have to look at the models that you can run from a NIM perspective. Remember, this is the trade-off, right? Again, the trade-off is video memory versus the 128 gigs of memory that you have on the official DGX Spark. So what we're going to do now is we're actually going to run the GPT OSS 20B model, okay? So Ollama list, Ollama PS. And now you can see that it's using 14 gig for 4096 context, right? And it's using 100% of the GPU, all right? And by the way, you can actually go in. Remember that we have the tools as well, right? To actually go in and look at real-time information on your GPU. Remember, we installed this in part 1 of our series. Okay. Now let me see here. Yeah, I don't think I can do that. Let's actually do this. What is the command to run nvidia and query every 3 seconds? This is what I love about Warp, right? You can actually go out and do that. Yeah, so so I had a little bit wrong. So it's watch-n3 NVIDIA SME. So basically what this is, and by the way, I can actually, instead of me typing this out, I can push it, right? And automatically it'll do it. So now I have this, every 3 seconds this will update. You can see here the temperature, right? 30%. The utilizations, the memory utilization. You can see here it's using 12 gig. So let's go in now to Open WebUI and select GPT OSS 20B, and you can see here it's green. Okay, and so now what we're going to do is let's remove this chat. Okay, and we're going to say show me a code snippet. Now this is a bigger model. You saw that there was a little bit more delay than the Nemotron model. And the reason why that is because it's a bigger model. Okay, bigger models tend to have a longer response, right? We call this time to first token, so TTFT. And one thing I want to point out is what you get with Ollama, what you don't get with NIMS. Okay. But before we do that, let's go back here, right? And you can see real-time usage, etc. During that process. And unfortunately, I didn't go back and look, but you can see this because it's actually polling every 3 seconds, this NVIDIA SMI tool, okay? All right, so let's go back here, and now you can see here. Now, one thing you don't get with NIM is this information toolkit, which I have to look a little bit further into, seeing how I can get that for NIM, because this is very valid information when you're testing models, right? You want to see the response, right? You want to see the total duration, how many prompt tokens, time to first token, how many completion tokens, etc. Right? The approximate total time it took to respond, right? Which is 19 seconds. Okay? The total amount of tokens. So this is what I'm talking about. All right? You want to be able to get this information to determine if this is a good enough model for your use case. And this is the point. I was just at a bunch of AI events for our company, and we had IDC, nvidia, Intel, AMD, other professionals, right, in the room talking about this. And one of the key things that came up is the fact that many organizations, many customers, are using these large language models, massive models, and they're wasting money. And the reason why they're wasting money is because they believe they need these large language models for everything that they do. And that's not the case. All right? Especially when it comes to agents. You may need one large reasoning model, but your other agents or your sub-agents that it connects to may be experts in specific areas. And so small language models could be used in those cases where you're not having to waste GPU memory, right? And cost, right, when it comes to token per watt per dollar. All right, so make sure you keep that in mind. So now that I have both, I've actually tested both, and I can go back in to Ollama. Let's Control C out of here, and I can do an Ollama stop GPT-OSS20B, Ollama PS, and you can see here basically I stopped that container from running, and now I have no models running. I have the model file and files downloaded and stored, ready to consume, but I have no models running. So what happens if I want to look at other models? So let's go to Ollama model list library. These are very popular models, by the way. Qwen is a popular model. DeepSeek is banned in the US, so we won't use it here. Qwen is from Alibaba, so you have to really question the source. Again, I see a lot of this on Reddit, and I see a lot of Americans really talking about Qwen and DeepSeek and things like that. And I'm thinking to myself to me, you have to be very careful on how you use those models, right? They certainly have built in to the training of those models, certainly an aspect of bias that you have to be very careful of, even though they're very good. There's another model that just came out. It's actually it's here. Hang on one second. It's called Kimi K2. They say it's one of the best models that's come out thus far. The problem with Kimi K2, it's from China, right? So you have to be very, very careful. So, I don't know what it is, but I see a lot of folks that are not thinking, they're thinking how great the models are and how they respond, but they're not thinking of the repercussions of using a Chinese-based model, which has bias. Okay, so you have to be very, very careful in those cases. Let's go back to let's go back to Ollama, and you can see here Mistral, right? So let's do this. Let's look at a Mistral 7B, and that's what we'll do. We'll actually do the latest, actually. So let's do a Mistral 7B. So all you have to do here is you have to go back into your command line and do Ollama pull Mistral, and what was it? 7B. Okay, so that's now downloading the model, and it'll download the model in that directory which I talked about, right? And we'll go in and look at that, and then it'll actually kick it off. So it's going to take a little bit to actually download, and then start. So you can see here that, I actually added this NVIDIA wallpaper here to make it seem like a DJX system. But you're getting a lot of the DGX functionality, right, using these other tools, using tools that you would leverage on DGX as well, right? The other thing, too, is this is x86. The DGX is ARM, so it's basically an ARM architecture that's interfaced with the Grace Blackwell architecture, okay, from a GPU perspective. I do write in this article, in part 2 of the article, about the trade-offs. One of the trade-offs being that even though the memory is large, okay, from a DGX Spark perspective versus the RTX 4000, the RTX 4000 has a better memory bandwidth. It has about 150 or 100 megahertz or so better memory bandwidth. One of the things, the other trade-off is that the tensor cores, right? So essentially the RTX 4000, the DGX Spark has twice as many tensor cores as the RTX 4000, and they're next gen, right? They're the Blackwell generation, where I'm using the Ada generation tensor cores. Okay, so there's some benefit to the DGX Spark there as well. And again, I'm not trying to talk you away from the DGX Spark. The idea of this is to look at your requirements and see if a do-it-yourself workstation might be more beneficial than the DGX Spark. And I've made this small. And by the way, that's another trade-off too, right? Because you can go and get yourself a 3090, right? RTX 3090 or a 5090. And you'd be around the same price as the Sparks. You're better off just getting the Spark. The thing about this 5090, right, is you're getting 32 gigs of memory, but it's very, very fast from a memory throughput perspective. All right, so if you're okay with the amount of VRAM on the 5090 or the 3090 for that, even for that matter, you'll get much better bandwidth than the DGX Spark will, or much better bandwidth than what I'm showing here. I built this system to be the same footprint as the DGX Spark, and that's the reason why I chose the RTX 4000 SFF Ada. Another GPU you could use is the NVIDIA L4, which has 24 gigs of VRAM. The problem with that is it's much more expensive than the RTX 4000 is. Okay, I think it's around $2,800. The RTX 4000 you could probably get used now for under $1,000. The 3090, which would have more memory than this, I think 24 gigs of memory, so you'd have 4 more gigs of memory, would be roughly $600 to $800, I believe, at this point for a used 3090. Except now you'd be forced into more of a bigger platform, right? And that's the reason why I chose to build this. So let's go back in to Warp and see where we're at. And now we're going to run it. And you can test it here, by the way, but I like to test it within my Mistral 7B is set up now, and now we can go in here and ask it the same question. New chat. Show me a code snippet. So this is Mistral 7B now, okay? And you're actually looking to see if you can get a better outcome, right? Maybe, even though the GPT OSS is a 20 billion parameter model, this is a 7 billion parameter model. Generally speaking, obviously the more parameters that you have, I say generally speaking because not all the time, but generally speaking, the smarter it is, right? The better outcome you'll have. In this case, let's see, we got 52 tokens per second. Total tokens was 642. If we go back to this, we had 60 tokens on GPT OSS, and total tokens were 1210, right? So more than likely, if you compared the two, or if you asked it a direct question and compare the two, GPT OSS 20B will have a more accurate response, right? But the idea is to compare the two to see if the response is accurate enough on the 7 billion parameter model. That way I'm only leveraging a smaller amount of VRAM, right? So that goes back to token per watt per dollar. Okay, so I hope you liked this video. This is just basically the Ubuntu side of the do-it-yourself DGX workstation that I built in comparison to Spark. As you've seen in this video, I talked about the trade-offs, certainly, and I talked about the use cases, I believe, for each. Again, in my use case is really focused on inference. Small language models, right? Not so much larger language models. I would say GPT 20 OSS 20 billion parameter model is probably the best model out now that I would leverage for the 20 gigs of VRAM that I have. And the reason I say that is because I won't use the other models that I showed, right? I won't use Quen or DeepSeek or any of those other models because of the perceived bias that could come out of those models. You'd be very careful trusting anything from China, to be honest with you. So that's all I have today. In the next article, as we close out the do-it-yourself workstation, we'll actually boot into the Windows Pro side of it, and we'll look at some of the tooling you can leverage for Windows Pro. Some of it will be the same. You can leverage Ollama in Windows. You can do anything LLM. You can do LM Studio. There's a bunch of tools that you can leverage in the Windows side as well. So stay tuned for part 3 and the final part. And I hope you have a great day and you enjoyed the session. Take care.